problem.
Okay.
So an optimized way of solving a problem.
Okay. What is the meaning of optimized?
So it means in the shortest possible manner, or in the shortest possible time taken, so that we can suppose, let's say we
No,
need to reach.
that whatever you're talking, that is the how can we know that which algorithm is best? Okay. But I want to know first of all what is an algorithm and why algorithm is required. Anything, don't worry, anything, whatever comes to your mind, please tell me.
A set of instructions to write a program.
Set of instruction to write a program. Okay.
So it is a set of instruction or the rules that are required to solve the basic problems.
Okay, can you please tell me what is the difference between an algorithm and a program?
So algorithm generally includes the means stepwise steps. So
Okay.
in a programming we generally do the simple means directly we do
So
compute.
can we say that any algorithm we can write in using any programming language? Any algorithm we can implement using any programming language. So algorithm is program dependent or not?
So it is not program dependent.
Yes. Suppose we want to add two numbers, so we can write algorithm addition of two numbers. Okay. But so algorithm we can write an algorithm of addition of two numbers, but we can implement that algorithm using C language, C++ language, Java language, Python language, or any other language. Okay. So what is an algorithm? Algorithm can be infinite steps or not?
No sir, it has finite steps.
It's a finite step. So can we say algorithm is a finite steps to solve a particular problem?
Yes, sir, we can say that.
We can say that. Why
Yes, sir.
we say finite steps? Because any algorithm there must be a starting position and one of this ending position. Okay. So any algorithm must be finite. And what is the task of any algorithm? We can write a finite steps to solve a particular problem. Why we are saying this word particular?
Sir, it just solves one problem, not all the problems.
Yes. Suppose we want to add two number and later we want to add 5 number. So can we write on one single algorithm?
Sir, does the algorithm allow only two number or more than that number?
Okay. No, only 2 and another one is only 5. We want to add 2 number and want to add 5 number. Two different questions.
Sir,
Can we write a single algorithm?
Yes, sir.
Yes,
Yes.
How?
sir. We can use a dynamic array. Like
We can use dynamic array, but my question is very specific. There is no question like n. I am not saying about small n. N can be any integer number, any positive integer number. Suppose when we are talking about dynamic, suppose you want to add 2 number, 3 number, 5 number, 10 number, 1000 number, 1 lakh number. So n can be anything. So we can write a simple program for addition of n number. But if we want to only particularly add 2 number and add 5 number, can we write a same program? In only single program? Are you getting my question or not?
No, sir, not the same algorithm. We need two algorithms. Sir, can you repeat your question, sir? Not able to
We want to add only 2 numbers. Okay, we want to add only 2 numbers. That is one question. And another question is we want to add only 5 numbers, not more than that, not less than that. And one question is we want to add only 2 numbers.
So we
Is it possible to write a single algorithm?
Yes, sir.
No,
So we can
How?
present a menu.
Sir, if we represent like if we pass something as a parameter that counts the number of summation we want to do.
Okay, that is generalized, not a particular. I want to
Yes.
say particular. It is generalized. What you are saying generalized.
Yes.
It is not possible to write one algorithm which can be add on 2 numbers and also 5 numbers. It's only 5 numbers or only 2 numbers. Okay, suppose forget about that. Suppose we want to write an algorithm for sorting and another algorithm for searching. We have 2 problems. Suppose we have 10 numbers. First question is we want to sort, and second question is we want to search any number from that group of 10 numbers. Is it possible?
yes, sir, it is possible.
No. In a single algorithm, is it possible? Sorting and searching, both together in a single algorithm. In a single program, it is possible. Don't mismatch between program and algorithm. In a single program, it is possible. And in a single algorithm, it is possible.
No, sir, it is not, sir.
No. In a single program, it is possible. Okay. In a single program, we can implement multiple algorithms. Okay. Or when we design a software, we can use multiple algorithms. But in a single algorithm, it is not possible for searching and sorting both. So algorithm is nothing but a finite set of steps, okay, to solve a particular problem. To solve a particular problem. Okay. 1 minute. Now, what is the algorithm or what are the component of any algorithm? Suppose we want to make a cup of tea. What is the first step?
So, take milk.
No, first we need ingredients. Okay? First we require ingredients. That means what are those? What are those? We can say these are all input. Right? So first one is input. Yes? Any question? Okay, first one is input. What is the second step?
Process.
Process. Third step,
Output.
output. Okay, so process may be different. Okay, process may be different. But suppose we want to sort 5 numbers. Okay, we have different 5 integer numbers. Okay, and we want to sort 5 numbers. We can sort in many different ways to sort 5 numbers. Yes or no? Suppose we have three different approach to sort 5 numbers. Yes or no?
Yes, sir.
Okay, just a second. Yes? In 1 minute. Is my screen visible to you?
Yes, sir, visible.
Okay. So suppose we have 5 numbers. Suppose 10, 3, 18, 5, okay, and 20. Okay, we have 5 different numbers. Now, what is our aim? According to the question, we need one to sort. So these are called input, yes or no?
Yes, sir.
Now,
Yes, sir.
what is the output? We want to sort in ascending order. What is the output?
3, 5, 10.
3,
5,
5, 10,
18,
18, and
20.
20. Okay? So this is the output. Now we need to process these 5 data so that our output like this. So there are different methods. Suppose there is method 1, method 2, method 3. Okay? Suppose there are 3 different methods. Using 3 different methods, we can sort these 5 numbers, and what is the output? Output is this. Okay, 3 different way we can sort. Okay? Any question? Okay. So 3 different way we can sort. So similarly, when we write any algorithm, there is one. When we write any algorithm, there is one input. Then input goes to, there is some we need to process. Using those input we need to process, then we will get output. Okay? So how to process? There are 3 different algorithms. Suppose algorithm 1, algorithm 2, and algorithm 3. So algorithm 1, it dictate any one method, A2 depicts any one another method, A3 represent another method. So A1 represent one method, A2 represent another method, A3 represent another method. Okay? So any algorithm, there was an input and what output. So input and output is same. Okay? Because input is this, output is this. What is our task? Our task is sort. Okay, our task is sort this 5 positive integer number. Okay. Now we can write 3 different algorithm. What is the 3 different algorithm represent? These 3 different algorithm represent that at 3 different method. Okay, 3 different process, and we can sort these 5 numbers. But output for 3 different algorithm is different or same? Output same. Output always this 3, 5, 10, 18, 20. Okay. So now tell me, is any algorithm is input dependent? Any algorithm is input dependent or not?
No, sir.
No. So suppose we want to
No,
sort.
sir.
We want to sort 12, 30, 90, 5. Okay, this phone number. We can apply same 3 different algorithm. We can apply any of the algorithm. So in our algorithm, what is the task of my algorithm? Our algorithm want to sort any number. Okay, any kind of number, maybe 3, 4, 5. Okay. So algorithm is not input dependent. Is it output dependent? Any algorithm is output dependent?
Yes, sir.
Okay.
Yes, sir.
Output dependent means yes or no. Suppose we apply this input, then output is this. Suppose we apply this input, the output is different. Output is 5, 12, 30, 90. Okay. If we apply this one, this 5 number, the output is this. If we apply this 4 number, then output is this. So it is not output dependent. But any algorithm start with as an input and process the data, then we'll get some output. Okay. Now you tell me, sir, we can write any program directly. Why we need algorithm? You please remember what is flowchart? Anyone please tell me what is flowchart? You know, I know that you know this answer. What is flowchart?
So simply a diagram to solve one problem.
A pictorial representation of any algorithm. Can you say pictorial representation of any algorithm? Okay. So pictorial representation of any algorithm is called flowchart. You can see there is a start button. Okay. Then there is a input. Input is this rhombus kind of thing, no? Then processed. Okay. Then output. Okay. Then stop. Again stop. Oval. Okay. So pictorial representation of any algorithm is called flowchart. So why not we can write any program directly? Why we need algorithm? Suppose when we want to solve any problem, okay, okay. So there are three different way to make a cup of tea. 3 different way for making a tea. Which one you choose?
Simple way.
The easiest one.
Simple way. Okay. What is the simple way? How do you know? Because it takes same amount of time. Process is different.
The less.
Or it takes less amount of time. Process is different. What is the meaning of simple way?
So process different, less amount of time.
Yes, means 3 different way, 3 different process, but it will take less amount of time. Whichever is, or sometimes it takes more time, but it should be tasty. Okay. Taste also required. Okay.
Yes, sir.
Similarly, okay, so we can write 3 different or 4 different algorithms to solve a particular problem. We can write 3 different ways to solve any particular problem. So, but how do we choose which one is better? Okay, how do we choose which one is better?
The least time complexity. Whichever algorithm has the least time complexity.
Yes. Suppose next slide. Okay. Suppose we have A1, A2 and A3 algorithm, 3 different algorithms to sort n numbers, in any positive integer. Okay. So we have three defined algorithm, A1, A2, A3. Okay. And these three, what is the task of these three algorithm? Using these three algorithm, we can sort n number of element. What is n? N any positive integer. Okay. Now tell me, now we want to implement, we want to write a C program. Which one can we write? We can write a C program for sorting any n numbers. Which one we prefer? A1, A2, A3.
एग्जाम्पल अरे इंट्रोडक्शन आज कोई पढ़ा नहीं रहे वो
Hello.
फाइनल स्टेप प्रोसेस होता है वो
Hello. Which one we prefer? A1, A2, or A3?
So which take less time in an effect?
Sorry. Please repeat again.
हाँ लेकिन इसे चलते हैं ना तो एक नंबर है उसका इतना में चला ये खत्म हो गया
Hello. Please mute your mic.
और oh sorry sir
Okay. Which one we prefer?
Sir, less time consuming.
Less time. Less time means suppose A1 it has it will take 10 millisecond. Okay, it will take suppose 10 millisecond. So suppose when we implement this A1 algorithm into a program, then it will take suppose 10 millisecond. Okay, i3 processor and 68 GB suppose RAM. Okay, i3 Intel processor and A2.
Excuse me, sir.
It will take suppose 5 millisecond.
Excuse
Okay,
me, sir.
i7. Yes.
Sir, one of my friend is trying to log in, but he can't.
Okay. Excuse. Sorry. Now it is okay?
Yes, sir, I think.
Okay. Now, so we have two different algorithms. One second. One is A1, another one is A2. Okay. To solve, to sort n number. Where is n is positive integer. N is positive integer. Okay. Now, A1 and A2. Now, if we write a program for A1 algorithm, and it will take suppose 10 millisecond, okay, and if we implement A2 algorithm, it will take 5 millisecond. Okay, which one is better?
Which take 5 milliseconds.
A2
Okay, but when it is possible, this 5 millisecond execute in i7 processor and this one execute in i3 core processor. Then, can we compare?
No, sir, we can't compare.
Okay, so when we execute any algorithm, when we convert any algorithm to program, then execute, there are many different environment. Okay, suppose we can execute in i7 processor 16 GB RAM or i3 processor 32 GB RAM or i3 processor 16 GB RAM, i7 processor 32 GB RAM, and different someone use SSD. So different multiple environment is induced in this when we write program. So that's why when we write any algorithm in terms of time complexity means order, okay, we can compare between two A1 and A2. Okay, so when you going into details in subsequent classes, so you can understand that which one is better, A1 or A2. How do you calculate? Using some notation, using some mathematical notation. Okay, using some mathematical notation, we can compare two different algorithms. Okay, so as a computer scientist or computer engineer, what is our task? As a user, forget about the computer engineer. As a user, which one you prefer? Suppose you have written two different software. You have built two different application app. Okay, you have defined two different apps. Which one is you want to use? Suppose application 1 and another one is application 2. Both are used for ticket booking. Suppose both are used for flight ticket booking. Which one you want to use?
So user friendly app. The
First one is user friendly.
More user friendly.
Both are user friendly.
Sir,
Then
the less time consuming.
less time consuming. We need fast processing. Okay, we need fast processing. Okay, suppose if application 1 it's required very much more time than application 2. It will take suppose 10 minutes. Okay, and it will take suppose only 2 minutes. So always we prefer application 2 because it will take less amount of time. Okay, so that's why running time is very, very important. Okay, running time is very, very important for any efficient algorithm. Okay, to design any efficient algorithm, running time is very, very important. So always we prefer small run time. Always we prefer small running time. And another one is, suppose application 1, if you want to install application 1, it will take suppose 30 MB memory. And if you want to install application 2, it will take, it will take suppose 12 MB memory. Which one you prefer?
Application
Obviously
2.
application 2. Okay?
Yes, sir.
So, it will take, okay, less memory. It will take less memory. Okay? So, when we design any algorithm, what is our aim? It will take small running time and it should take less memory. Okay. So, now when we are talking about the memory, what type of memory it is? Nowadays, secondary memory is very, very cheap. SSD card we can use 1 TB, 2 TB, 3 TB, 4 TB, whatever is very less. So, what type of memory are you talking about? Yes?
Primary memory.
Yes, RAM. Excellent. Very good. We want to talk about RAM, randomly access memory, or we can say it is called primary memory or primary memory or RAM. Primary memory or RAM. So data structure, why we need data structure? To store our data in such a way that, why we can store those data? In our primary memory or RAM. So to store data into our primary memory or RAM in such a way, efficiently we can use this. What is the meaning of efficiently? We can access very easily, we can update very easily. Okay? Yes, we can insert any data into our primary memory or RAM, we can delete any data, we can update any data, we can perform some operation using those data. Okay, so we can perform efficiently. Efficiently means what? It will take less memory space and small runtime. So do you understand what is the linking between data structure, okay, and algorithms? So that's why our subject name is data structure and algorithms. Okay, algorithm depends on data structure. We can write algorithm using data structure, efficient data structure. Suppose you want to sort n number, which data structure we need to use? All of you have already used this one in first semester. second semester, I think. If you want to sort n number, or if you want to search any n number, only one number from n number,
So array.
array, right? So
Array.
already we have used one data structure. What is this? 1 minute. Okay, already we have used one data structure, which is called
Array.
Array.
array. What is an array? What is an array?
An array is a
What is the
collection of
features? What is
similar.
the features? I don't want to know exact definition. Just tell me what is the features.
Sir, it stores multiple data of the
collection.
same type.
Yes, it store similar type of data. Okay, it store similar type of data. Okay, using array in a single array, please listen my question carefully. Using any single array, can we store our name and roll number both?
No,
Using
sir.
a single
Yes, sir.
array, can we store our name and roll number both?
No, sir.
No, sir.
No.
No,
Suppose
sir.
and roll number both are different type. Okay, both are different type. Name is a string. Okay, string data type, and roll number is integer.
Integer.
So to store name and roll number, how many array required? 2 array required. 2 string type array. What is string? It is nothing but character array, and another one is integer type array. But we want to store one person. If you want to store name and roll number together, how can you store? You know. Please remember. Please recall.
The structures.
Structures.
Yes, please. Yes.
Structure.
Structure.
Function. Structure.
Structure, not function. Right. Very good. Structure. So using structure, we can store multiple types of data. So this is the difference between array and structure. Using array, we can store functional difference. Using array, we can store only same type of data. And using structure, we can store different type of data. Okay, this is the functional difference. And what is the structural difference? In memory, what are the difference? When you store, suppose 5 integer data within an array, how it is stored?
Sir, in consecutive memory allocation.
Yes, it's stored sequentially. Suppose if integer takes 2 bytes, so first address is suppose 100. What is the next address? To store one integer data, we require 2 bytes of memory space. So, yes, first base address is 100. Next address is 102. Next address is 104. That means what is the meaning? What is the meaning?
Sir, it is consecutive and sequential.
Yes. So how it is consecutive? It is suppose here we store 10. In 102 we store 20. In 104 we store 30. So is it consecutive? 101. What is 101? This is not consecutive. You are saying 100 consecutive, but first one is 100, next one is 102. What is 101 or 103?
It's not consecutive.
It is not consecutive. No.
So it is in the 101 is between 100 means.
So 101 store which number? 10, 20 or 30?
10.
10, right?
10.
Because this is 100, this is called base address, first starting address. This is 101. This is our memory. 102, 103. Okay. Now, these 100 and 101 together can store value 10. 102 and 103 together store value 20. But if you want to know what is the address where we store value 20, only we are saying the starting address 102. What is the address where we can store 110? Where we store this value 10? It is 100. Now this sequential. But structure, okay, we will go in details in next class in structure. But structure, value stored not in sequential manner. One value stored in one location, another value stored in different memory location into our primary memory or RAM. Up to this, any doubt?
No, sir.
Okay. So in the next class, we will discuss array, structure, and pointer. So what is a pointer? Array structure both are memory.
Stores the address.
Shows the address.
The pointer is something that shows the address of the
Now
data.
tell me, is it a pointer? It is a pointer. This symbol, you can say, is it a pointer?
No, sir.
Why not? It's point something.
Sir, with
Pointer means what? Pointer means point something. Okay. So what is a pointer? Pointer, it stores the address of any variable. Okay. Pointer store the address of any variable. Okay. Yes or no?
yes, sir.
Okay. Just a second. Okay. Suppose int, sorry. Suppose int a equals to 5. Okay. Now int pointer p. What is the meaning a equals to 5? That means into our primary memory or RAM, there is one location, suppose 1092. And here we store 5. But as a programmer, how do we know this is 1092? So that's why this memory location we address by A. Okay? So A is a variable, or which kind of variable? Integer type of variable, and it store a value 5. We can change the value. Suppose that's why it is called variable, right? Later we want to store here 15. So the value is 15. And P, what is the meaning of this int pointer P?
So it is a means
The pointer
data type
for-
of integer pointer. The P is data.
Data type of integer pointer. It is an integer pointer.
Yes.
What is the meaning of integer pointer? P, it is an integer pointer. P
is a pointer
It's
which
a
indicates
integer
the
pointer.
address of an integer.
Yes. That means P is a variable, okay, which store the address of any integer type variable. I repeat again. P, it is a variable which store the address of any integer type variable. That means this is P. Okay, P. So suppose P, it has own address, suppose 3090. What is the value of P? Suppose if we write
1092.
P equals to ampersand A. Okay, so what is the value of P?
1092.
1092. What is this operator? This is called, you know,
Address ampersand.
Address of
Address of, right? Address of operator. So address of A. What is the address of A? 1092.
1092.
So P hold the address of any integer type variable. So that's why it is integer type pointer. Can we store here? Can we store within this P? Suppose we declare float. We declare float P equals to A equals to 10.5. Can we store A within this P? Can we? No, because we declare P, it is an integer type pointer. Okay, so we cannot store the address of any floating type variable. This the meaning is that P is a pointer which store the address of any integer type variable. Okay, so P it is an integer, so A it is an integer type variable. So here we store the address of A. Now if we write pointer P, if you want to print pointer P, what is the value? What is this value?
Value of.
Value of, no value of, value at operator. This is address of and this is value at P. Okay, what is P value? 1092. What is the 1092 value? 15. So asterisk P is 15.
15.
Right? Value at P. What is P? 1092. What is value at 1092? 15. So output is 15. So pointer holds what type of data? What is the type of this data? What is 1092?
Address.
Address. Type. What is the type of any address?
Integer type.
No, not only integer.
Data type pointer.
Unsigned integer.
Yes.
Unsigned. Can you say it is a plus 1092 or minus 1092?
Plus 1.
No, address always unsigned, not positive, no negative. Okay, not positive, no negative.
Yes, sir. Not negative.
Unsigned integer. Okay. So now I hope you can understand what is the relationship between data structure and algorithm. Have you used any data structure in everyday life? Suppose if you went to any ticket counter, you can see first person get the ticket first. Now next person. Okay. So similarly, if you want to build any software for flight booking, railway reservation, bus reservation, anywhere, okay, so who opts the ticket first, he get the ticket first. Okay, so there we need to design a data structure in such a way that we need to store opt first, who opt second, who opt third. So accordingly, we can allocate the ticket. We can allocate the ticket. Another simple example. Suppose we want to search data. Okay, suppose we want to search data from dictionary. We want to search data from dictionary. How to search data from dictionary? What is the meaning of data? How to search anything? Suppose you want to search what is the meaning of bird from any dictionary. How to search?
So firstly we will.
Sir, we have to find the where P letter start.
First
B
we
must start.
search B. Where is B start? Then BI. Am I right?
Yes,
Then,
it will be sequentially, sir.
then BIR. So you can see here what is the use of data structure. Suppose all the data, all the words are in jumbled way. Okay, all the words are jumbled, and if anyone tell me, your friend tell you, okay, what is the meaning of word? Your sister or brother tell you that, Bhaiya, what is the meaning of bird? Is it possible to search easily?
No, sir, it is difficult.
No, it is not. So that's why you can see in daily life also, this is one of the beautiful example of data structure. Okay, another data, suppose you want to search any name from your search list in your phone. Okay, from your contact list, if you want to search any name, can you see how beautifully data is stored? All the A, suppose you want to search Abhay. Okay, want to search Abhay. So first it's check A, then AB, then ABH. Yes or no?
Yes, sir.
Okay.
Yes, sir.
So there are many different applications where we can use data structure. And using those data structure, we can implement, we can write any algorithm. And why we need to write algorithm? To solve any particular problem. Any question, students? Now you can understand what is the difference, what is data structure, what is algorithm, what is the relation between these two. Yes or no?
Yes, sir. Got it, sir.
Yes, sir.
Okay. So in this course, we will be able to understand here, okay, concept of data structure. Is it visible?
Yes, sir. Visible.
Yes, sir.
Concept of data structure, data type and abstract data type. Student will be able to analyze algorithm and determine their time complexity, implement linked data structure and solve various problem arrays. Okay, so when we implement the apply standard algorithm for searching, sorting. Okay, but what is the this is our outcome. Okay, ये हम सीखेंगे linked list, data structure. This is our outcome. But what is our objective of this course? Understand the different way to represent different kind of data. How we store different type of data into our primary memory or RAM. Okay, how in different way we can store our data into our primary memory or RAM. You can already know that using array or structure we can store different way. Yes or no? Using array or structure to different way we can store in our data, same data, to different way into our primary memory or RAM. Another objective of this course is operation perform different representation of data. Here we can insert any data, we can delete any data, we can update any data, we can search, we can perform sorting. Okay, so different type of operation we can perform. But most important is this third one. Identify and apply the appropriate data structure and algorithm for a specific application. So this subject is not only important for this semester, this subject is important when you are going to for higher studies, or if you apply for any GATE exam or any interview exam, okay, or interview exam, and fifth sem you have another subject, design and analysis of algorithm, means higher version of this course. So that's why we need to understand this data structure and algorithm subject. Okay, and what is the objective of this course? Identify and apply the appropriate data structure and algorithm for a specified application. For a particular application, all these, which data structure is important? Suppose any air is a ticket reservation system or railway reservation system. Suppose if we get the ticket, who comes last? What happened? If we reserve the ticket, okay, who comes last? Then second last, then third last, and who came first? He or she opt the ticket at the end. Is it feasible? Hello.
Yes, sir.
Yes, sir.
Okay. Is it okay? So that's why appropriate data structure algorithm is required for specific application. Okay. So in this course, we're going to start first introduction, structure and union, pointer, dynamic memory allocation, algorithm specification, space and time complexity. Next topic, array. Okay, so we present dynamic memory allocation, polynomial, sparse matrix, diagonal matrix, then linked list, single and double linked list and their operations, single, double and circular linked list. Then we discuss stack, queue, okay. Then trees, graph, sorting and searching. Okay. This subject totally means conceptual. Okay. If you understood in the class, then you need to practice some question only. Okay. But understanding is very important for this subject. It is very totally one kind of mathematical type of subject. Okay, very easy, but very important also. Okay. So in the next class we will start from structure, union, pointer, dynamic memory allocation. Okay, we will discuss in the next class. And here we will discuss the marks distribution. You know, mid-semester examination 1 hour, 20 marks. Date will be notified later. Activity-based teaching learning throughout the semester, total 30 marks. End semester, 3 hours, 50 marks. Total 100 marks. Okay, total 100 marks. 20 marks mid-semester examination, 30 marks from activity-based teaching learning, 50 marks end semester examination. 30 marks activity means assignment and quizzes. Okay, I will give 2 or 3 or 5 quizzes and 4, 5, 6 assignment. Minimum 6 assignment and 6 quiz, or 2 or 3 quiz, 6 assignment. Okay, based on that, you will get this 30 marks. For late submission of assignment, your marks also reduced. Okay. And if you not appear for the first quiz or the first quiz, then for re-quiz, your marks also reduced. Okay, so this is your marks distribution. Mid-semester, 1 hour exam, 20 marks. Activity-based teaching learning, here we assign some assignment plus quiz. Okay, it is 30 marks. So end semester, 50 marks, 3 hours.
Sir,
Yes.
sir, do we have to use C as our language, or can we use C++?
No, only C. Lab always only C, and algorithm is not language dependent. Okay.
Sir, for
Algorithm
theory,
lab. Suppose I am not taking my algorithm lab, but this the DSA lab, right?
okay, sir.
Huh.
Sir, in theory exam, we may also get to write algorithms, right?
Yes, some algorithm are kind of problems. Okay.
So that has to be
Suppose
C.
some data is given. Okay, draw a different types of tree or write an algorithm for linked list. So one is algorithm is important and some question. How do we represent one polynomial function using an array? How do we represent one polynomial function using pointer, using linked list? Okay, it's this kind of problem. We'll discuss.
That
Many
has to
problems
be
we'll
in
discuss.
C.
Hello?
So that has to be in C.
No. Means in pen and paper we need to write. No need to write
Yes,
any
sir.
program.
We don't have to write any programs.
No, that is the interesting thing in this course. Okay, there is no program. Only you need to write algorithm. Suppose there is some snippet of code, you need to find out what is the time complexity. Only that much. Okay, only that much. Mostly you need to write algorithms and you have to solve some mathematical type of problem. Small mathematical type of problem.
So like writing algorithm means we have to like show it in a flowchart or something.
No, not flowchart, step by step.
Okay, we have
Okay. Okay. Yes, we will discuss then how to write any algorithm. Okay. In this course, you will able to understand that how to write any algorithm in your own way. Okay. Suppose when you are going for any IT job, suppose there is a your team leader provide any task. Okay. What is your name? Yes.
Shifted.
Siprit, please design an algorithm for this particular problem. That algorithm is not, you cannot find any books. So you need to write your own algorithm. Then you need to write analyze. Then you give to that algorithm to the development team, and development team design those algorithms using different language.
Okay, sir.
Okay.
Sir, another question, sir. The theory is 1 credit or 3 credit?
Theory for 4 credit subject. You can see 4
Theory is a
credit.
4 credit.
3, yes, 4
Oh,
credit.
lab is different. Okay, sir.
Lab is I think 1 credit or 2 credit. I don't know exactly. But theory 4 credit.
Okay, sir.
Okay. I will send this file lesson plan and as well as also the total course handout. I will send to your Google Classroom. Okay. I think few of the you don't till now not joined in our Google Classroom. Dipanjan not joined.